Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This second video lecture of week 8 for the course Applied Mathematics 1 is the continuation of my previous first video lecture. In the first video lecture of week 8, dear students, we have already learned about the Taylor series for a function. Now, in this second video lecture, we are going to learn about the Mclaren series of a function. For example, you see over here, to find the Mclaren series for the function f of x is equal to e power x square about x is equal to a, where a is equal to 0. Dear students, in the previous video lecture, I have already told you about the Mclaren and Taylor series. That Taylor series is for x is equal to a, for x is equal to a, and a will be any value, 0 and non-zero. So in the Taylor series, we can put a is equal to non-zero or equal to 0. But in the Mclaren series, this is the special case of Taylor series, that when we put a is equal to 0 in the Taylor series, the series will be a Mclaren series. So like you see over here, f of x is equal to f of a plus first order derivative of the function at x is equal to a divided by 1 factorial x minus a plus second order derivative of the function at x is equal to a divided by 2 factorial x minus a whole square plus third order derivative of the function at x is equal to a divided by 3 factorial into x minus a whole cube plus and so on up to n terms. N is sigma n is equal to 0 up to infinity. The nth order derivative of the function at x is equal to a divided by n factorial is equal to x minus a whole power n. So if we put in this series, this is actually the Taylor series. If we put in this series a is equal to 0, then the series will be the Mclaren series. And after putting x is equal to a and a is equal to 0, we obtained the series function value at x is equal to 0 plus the function first order derivative at x is equal to 0 divided by 1 factorial into x plus for second derivative of the function at x is equal to 0 divided by 2 factorial into x square plus third order derivative of the function at x is equal to 0 divided by 3 factorial into x cube plus and so on up to n terms. Sigma n is equal to 0 up to infinity. Nth order derivative of the function at x is equal to 0 divided by n factorial into x power n. So putting x is equal to a and a is equal to 0 in this Taylor series, we obtain this is the Mclaren series for any function f of x. But since in this problem we have the function f of x is equal to e power x square, so first of all put x is equal to 0 in this function to obtain the function value at x is equal to 0, and then find all these derivatives at x is equal to 0, and then putting all these terms like you see over here, f of 0, f prime at 0, f double prime at 0, f triple prime at 0, and so on. When we obtain all these terms, then putting the terms in this equations, this will be the Mclaren series. Like you see over here, putting x is equal to 0 in the given function, the function value at x is equal to 0 is equal to e power 0, and e power 0 is equal to 1. Now the first order derivative of the given function with respect to x, you see over here, exponential function derivative, exponential function will be as it is, and further derivative of the argument. Since the argument is x square, so the x square derivative with respect to x by using power rule is equal to 2x. So the first order derivative of the function is equal to 2x into e power x square. Now putting x is equal to 0 in this first order derivative, we obtain f prime at 0 is equal to 0, because x is equal to 0, so this term will be equal to 0. Now second order derivative of the function with respect to x, to take again the derivative of 2x, the second order derivative of this function 2x into e power x square. Now x into e power x square, both are functions and these functions are in multiplied form, so we will apply the product rule for the derivative. Like you see over here, first function derivative of second function plus second function is second function is e power x square and the derivative of first function. So x as it is, and the derivative of the exponential function is exponential function will be as it is, and further derivative of the argument, like you see over here, derivative of x square with respect to x plus e power x square, and derivative of x is equal to 1. Now after simplifications, we obtain the second order derivative of the function is equal to 2 into the derivative of x square is again 2x, and 2x multiplied this x will be equal to 2x square, and e power x square as it is plus e power x square as it is. Now putting x is equal to 0 in this second order derivative of the function, we obtain the second order derivative of the function at x is equal to 0 is equal to, putting x is equal to 0, this term will be 0, and e power 0 is equal to 1. So the second order derivative of the function at x is equal to 0 is equal to 2. Now to find the third order derivative of this second order, taking again derivative of this second order derivative, the derivative will be the third order derivative of the function with respect to x, since x is independent variable. That's why we take the derivative of the function with respect to x. Now the third order derivative, so taking the derivative of this second order derivative, then this will be the third order derivative, like you see over here, derivative with respect to x of 2x square in n to e power x square plus e power x square. Now in this term, this is again the product rule, so 2 and 2x square will be the first function, so first function as it is, and the derivative of the second function e power x square plus 2 e power x square, this is the first function, and derivative of the first function is x square. So again you see over here, x square is the first function and e power x square is the second function. So first function derivative of second function plus second function as it is, and derivative of the first function which is x square plus derivative of e power x square. Now 2x square and the derivative of e power x square as it is, and further derivative of the argument, so the derivative of x square with respect to x plus the derivative of x square with respect to x in this term is 2x. Now multiply 2 with 2 to the 4x e power x square plus the derivative of this term e power x square as it is, and further derivative of the argument which is x square with respect to x. Now so the derivative of this term will be 2x, and the derivative of this term will be also 2x. So you see over here, after simplifications, we obtained the third order derivative of the function is equal to 2 into 4x cube into e power x square plus 4x into e power x square plus 2x into e power x square. Now putting x is equal to a and a is equal to 0 in this third order derivative, the third order derivative of the function with this at x is equal to 0, we obtain this term will be 0, this term will be 0, and this term also will be 0. So the third order derivative at x is equal to 0 is equal to 0. Now the fourth order derivative of the function with respect to x, so taking again derivative of this third order derivative with respect to x, we will obtain the fourth order derivative like you see over here. So the fourth order derivative of the function with respect to x, it's mean that taking the derivative of the third order derivative of the function with respect to x, we obtain the fourth order derivative of the function like you see over here. Now for this derivative, simplify this third order result, taking common e power x square, we obtain e power x square into 4x cube plus 4x plus 2x. So now these are the two functions which is in multiplied form. So using the product rule for the derivative, you see over here, this 2 is it is, and e power x square is the first function, and taking the derivative of the second function, the second function is 4x cube plus 6x. 4x plus 2x is actually equal to 6x. So e power x square is the first function, and 4x cube plus 6x is the second function. So e power x square as it is, and taking the derivative of the second function plus this 2 is as it is, and the second function is as it is, and taking the derivative of the first function, which is equal to e power x square. So the derivative of now we take the derivative of e power x square and take the derivative of 4x cubed plus 6x. So the fourth order derivative is equal to 2 into e power x square plus the derivative of 4x cubed. By using the power rule, we obtain 12x square, and the derivative of 6x is equal to 6. And now plus 2 into 4x cubed plus 6x, and the derivative of e power x square, is it is, and further derivative of the argument is x square. So the derivative of this x square is 2x. Now 2 multiplied this 2 is equal to 4, and x is as it is, and 4x cubed plus 6x into e power x square is it is. Now putting x is equal to a and a is equal to 0 in this fourth order derivative, we obtained the fourth order derivative of the function. Actually this term is the multiple of x, so putting x is equal to 0, this whole term will be equal to 0, and 12x square is equal to 0. So 2 into e power 0 into 0 plus 6, so 6 multiplied 2 is actually equal to 12. So the fourth order derivative of the function at x is equal to 0 is equal to 12. Now putting all these results like you see over here, putting the results of the function at x is equal to 0, the first order derivative of the function at x is equal to 0, the second order derivative of the function at x is equal to 0, the third order derivative of the function at x is equal to 0, and the fourth order derivative of the function at x is equal to 0 in the series like you see over here in the previous slides. This is actually the series of the function. This is the Mclaren series of the function. So putting the value of f of 0, the value of f prime at 0, f double prime at 0, f triple prime at 0, f 4 time of the function at 0, the 4 time derivative of the function at x is equal to 0. So putting all these results, we obtain the Mclaren series for the function e power x square is equal to 1 plus 0 divided by 1 factorial into x plus 2 divided by 2 factorial into x square plus 0 divided by 3 factorial into x cube plus 12 divided by 4 factorial into x power 4. And now after simplifications, we obtained the Mclaren series of the function e power x square is equal to 1 plus this term is 0, and 2 factorial mean 2, so 2 cancel, so 1 plus x square plus this term is equal to 0, and the 4 factorial mean 4 multiplied 3 multiplied 2 multiplied 1, so 4 multiplied 3 mean 12, 12 and 12 cancel, 4 multiplied 3 is cancel, and now we obtain in the denominator 2 multiplied 1, so 2 multiplied 1 is equal to 2, so 1 over 2 into x power 4 plus and so on. This is the Mclaren series for the function e power x square. Now another problem to find the Mclaren series for the function f of x is equal to cos x. This problem is very easy. So dear student, you see over here, this is actually the Mclaren series for the function. To calculate the function value at x is equal to 0, to calculate the first order derivative of the function at x is equal to 0, to calculate the second order derivative of the function at x is equal to 0, and to calculate the third order derivative of the function at x is equal to 0. And putting all these terms, we will obtain the Mclaren series, and this is very simple. So first of all, putting x is equal to 0 in the given function, we obtain f of 0 is equal to cos 0, and cos 0 is equal to 1. Now differentiating the given function, the derivative of the function, and the function is actually equal to cos x, so the derivative of cos is equal to minus sin x, so the first order derivative of the function is equal to minus sin x. Now putting x is equal to 0, we obtain the first order derivative of the function at x is equal to 0, which is equal to minus sin 0, and sin 0 actually equal to 0. Now the third order derivative, the second order derivative, to take the second order derivative of the function, actually this is the first order derivative minus sin x. Now taking the derivative of minus sin x, this will be actually the second order derivative of the function. So the derivative of minus sin x is equal to minus cos x. Actually the derivative of sin is cos x, so the second order derivative of the function is equal to minus cos x. Now putting x is equal to 0 and this second order derivative, we obtain f double prime at 0 is equal to minus cos 0, and cos 0 is equal to 1, So the second order derivative is equal to minus 1. Now once again differentiating with respect to x. To find the third order derivative, for the third order derivative, take the derivative of the second order derivative with respect to x. We will obtain the third order derivative of the function, and the second order derivative is equal to minus cos x. So taking the derivative of minus cos x, we obtain sin x. Actually the derivative of cos is minus sin, so minus minus plus, so we obtain the third order derivative of the function is equal to sin x. Now putting x is equal to 0 and this third order derivative of the function, we obtain the third order derivative of the function at x is equal to 0 is equal to sin 0, and sin 0 actually equal to 0. So putting all these derivative, but if we find the fourth order derivative, the fourth order derivative is also very easy. To calculate the fourth order derivative of the function, taking the derivative of the third order derivative of the function, we will obtain the fourth order derivative. So the third order derivative is equal to sin x. So taking the derivative of sin, which is again equal to cos x, so this is the fourth order derivative of the function, which is equal to cos x. So putting x is equal to 0 in this fourth order derivative, we obtain cos 0 is equal to 1. So this is the fourth order derivative of the function at x is equal to 0, which is equal to 1. Now putting all these results, f of 0, f prime at 0, f double prime at 0, f triple prime at f triple prime at 0, and f fourth prime at 0. This is actually the first order derivative of the function, and f of 0 is the function value at x is equal to 0. This is the first order derivative of the function at x is equal to 0. This is the second order derivative of the function at x is equal to 0, and this is the third order derivative of the function at x is equal to 0, and this is the fourth order derivative of the function at x is equal to 0. So putting all these values in this Mclaren series, this is the Mclaren series, f of 0, f of x is the given function, f of x is equal to cos x. So the Mclaren series for the cos x is equal to f of 0 value is 1 and f prime at 0 value is 0. So 0 divided by 1 factorial into x square, and second order derivative of the function at x is equal to 0 is actually minus 1. So minus 1 divided by 2 factorial into x square, and the third order derivative of the function you see over here is equal to 0. So 0 divided by 3 factorial into x cube, and the fourth order derivative of the function is equal to 1. So putting 1 divided by 4 factorial into x power 4 plus and so on. So we obtain the Mclaren series for the cos function is equal to 1 minus x square divided by 2 factorial plus x power 4 divided by 4 factorial plus and so on. Now another problem, to find the Mclaren series for the function log of 1 minus 4x. So dear students, this is the Mclaren series of the function f of x is equal to, calculate the function value at x is equal to 0, calculate the first order derivative of the function at x is equal to 0, calculate the second order derivative of the function at x is equal to 0, and similarly calculate the third order derivative of the function at x is equal to 0, and then putting the values in this equation we will obtain the Mclaren series. So first of all, putting x is equal to 0 in the given function to calculate f of 0. So this is f of 0. So putting x is equal to 0, we obtain log 1, and the log 1 value is 0. So this is the function value at x is equal to 0, which is equal to 0. Now the first order derivative of the function is equal to, the log derivative is equal to 1 over the argument of the function log. So log derivative of log of 1 minus 4x is equal to 1 over 1 minus 4x, and further derivative of the argument is equal to 1 minus 4x. So the derivative of 1 is 0, and the derivative of x by using the power rule with respect to x is equal to 1. So 1 multiplied 4 is equal to 4. Now this is the first order derivative which is equal to minus 4 divided by 1 minus 4x. Now putting x is equal to 0 in this result, we obtain minus 4 divided by 1, which is equal to minus 4. Now for the second order derivative, we take the derivative of the first order derivative with respect to x, we will obtain the second order derivative. For the second order derivative, we can write minus 4 divided by 1 minus 4x as minus 4 into 1 minus 4x whole power minus 1. So in this second order derivative we can use the chain rule. So multiply this power with the coefficients, we obtain 4 into, and subtract 1 from the power, we obtain 1 minus 4x whole power minus 2, and the further derivative of the base 1 minus 4x derivative with respect to x. So the derivative of 1 is 0 and the derivative of x is 1, so we obtain in this term minus 4. Now multiplied minus 4 with this 4, we obtain minus 16. So the second order derivative is equal to minus 16 into 1 minus 4x whole power minus 2, and this is actually equal to minus 16 divided by 1 minus 4x whole square. Now putting x is equal to 0 in this result, we obtain the second order derivative of the function at x is equal to 0, which is equal to minus 16 divided by 1 minus 0 whole square, which is equal to minus 16. Now for this third order derivative, taking again derivative of this second order derivative with respect to x, we will obtain the third order derivative. For the third order derivative, we can write the given result of, we can write the obtained result of second order derivative as minus 16 into 1 minus 4x whole power minus 2. So for the third order derivative, now again using the power rule, multiplied this power with the coefficients, we obtain plus 32, and subtract 1 from the power, we obtain 1 minus 4x whole power minus 3, and further derivative of the base will be equal to, the derivative of this one will be 0, and the derivative of 4x will be equal to 4 with respect to x, like you see over here. So the third order derivative of the function is equal to 32 into 1 minus 4x whole power minus 3, and further derivative of the base. The derivative of the base is actually the derivative of 1 is 0, and the derivative of 4x with respect to x is equal to minus 4. So multiplied this 4 minus 4 with the 32, we obtain minus 128 divided by, we can write now 1 minus 4x whole power 3. Now putting x is equal to 0 in this third order derivative, we obtain the third order derivative of the function at x is equal to 0 is equal to minus 128 divided by 1 minus 0 whole cube, which is equal to minus 128. Now putting all the values for the function at x is equal to 0, the first order derivative of the function at x is equal to 0, the third order derivative of the second order derivative of the function at x is equal to 0, and the value of the third order derivative of the function at x is equal to 0, and this Mclaren series. F of x is equal to f of 0 plus f prime at 0 divided by 1 factorial into x square, f double prime at x is equal to 0 divided by 2 factorial into x square, and f triple prime at x is equal to 0 divided by 3 factorial into x cube, plus and so on. So this is the given function log of 1 minus 4x, which is equal to, now the function value of f of 0 value is actually equal to 0, and the first order derivative of the function at x is equal to 0 actually equal to minus 4. So minus 4 divided by 1 factorial into x square, and the second order derivative value of the function at x is equal to 0 is minus 16. So minus 16 divided by 2 factorial into x square, and the third order derivative value of the function at x is equal to 0, you see over here minus 128. So putting minus 128 in this term, we obtain minus 128 divided by 3 factorial into x cube, plus and so on. Now after simplification, we obtain the Mclaren series for the function log of 1 minus 4x is equal to minus 4x minus 16 divided by 2 into x square minus 128 divided by 6 into x cube. Actually 2 factorial is equal to 2 multiplied 1. So 2 multiplied 1 is again equal to 2, and 3 factorial means 3.2.1, which is equal to 6. So we obtain after simplification the Mclaren series for the function log of 1 minus 4x is equal to minus 4x minus 8x square minus 64 divided by 3x cube, plus and so on. So this is the required series for the given function log of 1 minus 4x. So dear students, this is the procedure how to obtain the Mclaren series for the given function. Actually the Mclaren series is the special case of the Taylor series at x is equal to a and a is equal to 0. So simply putting x is equal to 0, x is equal to a and a is equal to 0 in the Mclaren series, we will in the Taylor series we will obtain the Mclaren series. Putting x is equal to a and a is equal to 0 in the Taylor series, we will obtain the Mclaren series for the function f of x. So in the Mclaren series, dear students, you see over here, we need the function value at x is equal to 0, the first order derivative of the function at x is equal to 0, the second order derivative of the function at x is equal to 0, and similarly the third order derivative of the function at x is equal to 0. So first of all, find all these terms, f of 0, f prime at 0, f double prime at 0, f triple prime at 0, and so on. Then put the values of these terms in this Mclaren series. We can find the Mclaren series for the given function. Now this is the end of this segment. Thank you. Allah Hafiz.